remaining part is how to get the numbers, how to learn the network. We're just suddenly shifting into learning. Now, it's not the case that somehow only Bayes networks have to be learned. Logical representations have to be learned too. But this is a good place to go because people somehow think it should be possible to draw the topology if only somebody gives me the numbers. And the question is, where did the numbers come? Previously I said just ask the experts. Now this opens, take a deep breath, the entire area of machine learning. So this is your beginning into machine learning, okay? And I'm trying to make it such that you'll get direct algorithms and then theory later on. But this humongous amount of theory before getting into algorithms, but I'll just go into an algorithm right away. So that you have something that works and then try to figure out why, okay? So, how do we learn the Bayes nets? We assume that both the topology and the numbers are given by the expert. Now, of those two, which one is easier, you think, for the expert to give? In general, you have to learn both. But it's more likely that they might give you the topology and they'll be much more hard-pressed to figure out what the numbers are. So we will look at the easy case first, where we do have an expert who will give the topology, and then we'll try to learn the numbers from the samples. And then we'll get into the harder case, where there is no expert. There's only data. So you need to first make up a topology and make numbers for it. And then as you saw in that example, for any topology, you will be able to find numbers. The question will be which topology should you be picking? And this all brings up all the beautiful ideas of machine learning, such as overfitting, regularization, all that fun stuff. But this is our entry point into that world. Okay, so let me make it extremely simple, because this idea you should be able to understand. And then everything else follows. Imagine I have the simplest possible network in the world, a single variable network. I have a coin, and so the random variable is heads. It can be either true or false. And so basically I have a coin, and I went to the coin expert and said, what is the topology of the network? The coin expert, obviously overpaid expert, said heads is the topology. So you put a network with one node called heads. Then they'll stop. They'll say, I don't know the numbers. Okay. Now they might be saying, I think it's either 0.1 or 0.9. They could say that, right? I think I kind of forgot it's either 0.1 or 0.9. You figure it out. Okay. So now I have two Bayes networks, both with the same topology but different probability distributions, different CPTs. So their joint distribution is different. In this case, of course, joint distribution is the same as the single node name distribution. Right? Okay, so there are two topologies and same network. And the question is, now I then look at some samples. So because I'm trying to figure out a particular process for which this network is capturing that process, so I essentially went and found that these are some samples from the network. Samples from the network give you the valuations for each of the variables. Since this is the world's simplest network with single variable, it will only say heads true, heads false, heads true, heads false. I just wrote it as heads and tails. Okay, so sample 1, heads. Sample 2, tails. Sample 3, heads. Sample 4, heads. Sample 5, tails. Sample 6, heads. Okay, those are the samples you found. So my question is, which network do you think is the right network?
0.9.
My question is, which network do you think is the right network?
0.91.
Somebody else? Anybody has any idea why? So first of all, how many of you think that given this data, this is the right network? How many of you think given this data, this is the right network? How many of you don't think? Because of which you didn't understand my question, because natural language processing requires thinking. But, so the point is, you answered my question. How did you answer it? You answered it in the following reasoning. This is the data that is generated by the network. Whichever is the network that gives the highest probability to the data that has actually been seen is probably the network that was really there. Why? You know, another way of looking at it is, if you consider the probability of this data given this network, you would get heads with 0.1 here times, all these are independent samples. So the next one will come with 0.9 because that's tails, times 0.1 times 0.1 times 0.9 times 0.1. That's a nice, happy, small number. And if I do it this side, it would be 0.9 times 0.1, I'm sorry, times 0.1 times 0.9 times 0.9 times 0.1 times 0.9. These are both really, really small numbers, but one of them is hugely bigger than the other small number, right?
Yep.
Because this basically, I mean, previously you had a qualitative understanding that, oh, this network is likely because this is giving heads more than this. But I'm converting it into quantitative numbers. The likelihood of the data given the network is this number, 0.9 times 0.1 times 0.9 times 0.9 times 0.1 times 0.9. And given this network is 0.1 times 0.9 times 0.1 times 0.1 times 0.9 times 0.1. And this number is bigger than this number. So I believe this network is more likely network that caused the data. Do you see what I'm saying? That's it. That's learning. You're done. Basically, you will pick